Today we're diving into one of the most incredible journeys in all of nature, the story of how a new human life comes to be. We're talking about the whole thing, from that very first spark all the way to the moment of birth. It's a wild ride of microscopic precision and, well, marathon-level endurance.
It really all comes down to this one giant question, doesn't it? How on earth does a single tiny cell manage to divide and specialize and organize itself into a complex, breathing, thinking person? It sounds like magic. So let's unpack the blueprint of life itself and see how it's done. Okay, so first things first. Before any journey can start, you need the key players. And in our story, that means the fundamental building blocks of new life, the sperm and the egg cell. And believe me, how they're made is a fascinating process all on its own.
Let's start with how sperm are made, a process called spermatogenesis. Kicking off at puberty in males, you have the starter cell, the spermatogonium. It goes through this whole multi-stage assembly line. It grows, it divides, then it divides again, and finally, it matures into what we all recognize as a sperm cell, ready for its big mission.
Now get this, that whole intricate 5-step process we just talked about, it's not like it happens overnight. From that one little starter cell to a fully mature sperm, it takes, on average, about 74 days. A little over 2 months for the whole production cycle to complete.
All right, now for the other half of the equation, making an egg cell. And this is a totally different ballgame. It's not a constant production line like with sperm. See, a female is born with all the potential egg cells she'll ever have, and they basically just hang out in a state of arrested development for years, sometimes for decades. Only when ovulation happens is one released, and this is the crazy part, it only completes its final division to become a true ovum after it's been fertilized.
And this number really puts it all into perspective. At puberty, there are hundreds of thousands of these potential egg cells waiting in the wings. But over an entire reproductive lifetime, only about 500 of them will ever get the call to mature and be released during ovulation. Just a tiny, tiny fraction of the starting lineup.
So after all those years of waiting, once an egg is finally released, the clock starts ticking, and it's ticking fast. There is an incredibly narrow window of opportunity for fertilization to happen. We're talking just 12 to 24 hours. The pressure is definitely on.
So let's say that window is met and fertilization is a success. Well, now our journey really shifts gears. We're moving on from just creating the parts to actually building the whole thing. This is the 9-month or about 40-week construction project of a new human being.
And the pace of development is just mind-blowing. At only 5 weeks in, the foundation for the reproductive organs appears. Just 3 weeks later, by week 8, the first big body movements are already happening. By 12 weeks, the kidneys are working, actually producing urine. And by 24 weeks, the fetus can hear sounds from the outside world. It is an astonishingly rapid and organized process.
And take a look at this. This is what it all looks like at the very, very beginning. This isn't a diagram, it's a real photograph of a morula. It's just a tiny ball of cells only a few days after fertilization. Everything we're talking about, it all grows from this.
Okay, so to help us wrap our heads around all this, prenatal development is broken down into 3 key phases. You've got the ovular period for the first 2 weeks, then comes the embryonic period from weeks 3 to 8, and this stage is absolutely crucial. This is when all the major organs and body systems get built. After that, it's the fetal period, which is all about growth and getting everything ready for delivery.
And all of this incredible development, all this building and growing, it's all leading up to the grand finale of this 9-month journey, the process of birth, or what we call labor. This is it, the final passage from the inside world to the outside.
So what does a normal labor actually look like? Well, the medical term for it is eutosia. And really, the key things are that it starts on its own, right around the 40-week mark, it progresses smoothly without major delays, and it ends with a natural birth without any serious complications. That's the textbook version.
And the opposite of that is something called dystocia. It's a really simple way to think about it. Eutocia is the expected, straightforward path. Dystocia is basically the catch-all term for any labor that deviates from that normal process.
You know, for a successful birth, 3 big things have to work together in perfect harmony. They're often called the 3 Ps. You need the push from the uterine contractions, a clear passage through the mother's pelvis, and the passenger, the fetus, has to be in the right position to make the trip.
This whole process plays out in 3 main stages, or acts, you could say. The first stage is the longest. It's all about getting the cervix fully dilated.
The second stage is the active pushing part, which ends with the birth of the baby. And finally, the third stage is the delivery of the placenta.
But of course, biology isn't always so neat and tidy. Sometimes the journey of birth hits a detour or a roadblock. So let's take a quick look at what happens when the path doesn't go exactly as planned.
And this is a really important thing to remember. Not every journey follows the same map. Complications can and do happen. And this is exactly where modern medicine becomes so incredibly important in helping them navigate these challenges safely.
One of the biggest concerns is something called postpartum hemorrhage, or PPH. Now, while there are a few causes, by far the most common one is what's called an atonic uterus. That just means the uterus fails to contract back down the way it's supposed to after the birth. Things like a really long labor or carrying twins can make this more likely.
Another major challenge is obstructed labor. Now, remember our 3 Ps? Well, this is what happens when there's a problem with either the passage, like the pelvis is just too narrow, or with the passenger, like if the baby is very large or is turned sideways. The push is happening, but something is blocking the way.
And then, sometimes, the whole timeline just gets sped up. We call it preterm labor, and it's basically when labor starts before 37 full weeks of pregnancy are complete. This means the baby is arriving before reaching full term, which can bring its own set of challenges.
So when you just step back and look at the whole picture, a 74-day process just to create one of the cells, a 40-week journey of construction, and then a final multi-hour marathon to enter the world, it is an absolutely monumental undertaking from start to finish. It really makes you stop and think, what does this whole incredible biological epic tell us about the sheer resilience and complexity of life itself?